Hi, Mads from FlowHow. Now we have a part here where we want to add the cooling. You could also start from scratch with meshing the part and so on, but in this case I want to use a previous run where I only have a part with a gate and then try to add a cooling system on that. I'm using Molex 3D 2024 for this. So I start with copy the run. So I right click here and I say copy run, and I take this run put data, input data only. So now I'm actually in this run, but you can see the part is the same here. Um, I could keep the solid mesh and then just add the extra mold base and the cooling. But in this case, I would also like maybe to put in like a symmetry. So let's do that. Like if I had two cavities. So the first thing I do is get rid of the solid mesh, and I can do that the easiest way. Instead of me pointing this out and hit delete, the easiest way is actually go into the mesh and say generate keep attached solid mesh, no. And then it asks if I want to copy the run or continue. I just copied the run, so I just want to continue. And now you can see my model name got a different name. So now they are not connected anymore. So in this case, I would like two cavities, but only calculate on one. So I start, go here to the model, and I would like a runner. I can just try the runner wizard and see how much does it give me. It just gives me like this, but I want a line going in here and a bit up here and put on symmetry on that. But I'll keep this one. I'll take this one, mark it, hit delete, away with this. And then I'll go to sketch a runner line. So I'll go, in this case, I'll just do it by approximation. So go in here, and then I'll also from endpoint up here. And I'll add a point for the melt entrance here. And because it's lines, I can use this symmetry. If it was a solid, you need the symmetry from the boundary conditions in here. But anyway, I'll go back, and you just have to say this is a half. Okay. So now I'm added uh, two cavity mold and calculating on that. Um, Now we have to define, we have put in a runner system, we have a part with a surface mesh. I can show you the tool chisel. It's only a surface mesh. It's hollow inside. You see it over there. So now I have to add the mold base. I go to mold base here, and it gives me a size. Don't bother too much about the size. The most important is just that you have the runner inside, and yeah, and the part. The size isn't that important because if you, for example, have put cooling around here, around the part, it the temperature out here is not really dependent on what's happening inside here, because it's like um, the heat can't don't make any radiation um, through the cooling channels if you have enough water and are able to remove all the energy from the part, then the, there will be no radiation or convection uh, con- out in the other areas. So don't care about the size of the mold. Um, I'll go for this, and then I need to add some cooling channels. Of course, you can import cooling channels and so on, but what I'll do here is I'll just use the cooling channel wizard, and I want them to go the other direction like this, and I'll and can use the scroll mouse here, 8 millimeter in diameter, two pair of two. Maybe I should go for three. Yeah, because then I have one in the center here. Um, and maybe I'll use the scroll still. I'll go a bit longer out and a bit away. In simulation, it's a good idea to choose not that perfect cooling from the start, maybe, because if you can show that you can make good parts with very simple cooling, then you have a plenty of room of making the mold even better in reality. Um, so in this case, I'll say, okay, a cooling like that is okay. I'll try with that. And the cooling chance you're able, if for example you want this moved a bit, um, I'll get rid of, I'll just hide the mold base. You can mark everything here, and then you can say tool, move this, and in this direction, maybe 3 millimeters, I don't know, and move it. I'll just say undo, but you're able to move around with the cooling channels. I also want cooling up in that area here. So in this case, I'll just take this, move a bit downwards, of course not outside the mode base. I'll just check, yeah, it's not outside. And then I want baffle cooling up here, and yeah, just to take the heat out here. Maybe you could also do it here, but anyway, I'll just do it here. I'll go away from this to this here, and then I'll draw a help line, a line from the center of there, yes, and in this direction, yeah, I'll just make it long enough, and then it ends out, of course, directly on the surface, but you can't have a cooling, of course, going so high. So I'll move it backwards 10 millimeters. So I'll just use this, I'll mark it here, say move, and I'll say move in that direction. And I hit 10 and move it. So now it's moved 10 millimeters. I got this in the center, I think, but it will show me, because if I can split it, there is a connection between this line and this one. If I take this one and say attribute and say none, you can see it's actually just a line. So I'll split, tool, split this line, yes, with this line, yes. So now I think they are not totally aligned. So what I can do is I can mark these three things, and I can say move here, and then I can take a direction by hitting tabulator. I lock the direction, I can't go anywhere else, and then I can use this as a reference, like this. Then they should now cross each other. So I'll try again, trim, now split this one, yes, with this one. And now you can see now it splits, and I'll do the other one. Also split this one, enter, with this one, enter. And I'll delete this one. Mark it, hit delete. So now I have these two. These are, I mark them both, and then I'll say I can attribute and go to cooling channel, and I'll also make this one cooling channel. Sorry, that cooling channel, but it should not be just a round channel, because I want a baffle where the water is going up on one side and down on the other. 8 millimeters seems reasonable. So I'll, instead of a regular channel, I take a baffle. And a drill tip, that's the top. I'll say angled, like this. And yeah, the other thing seems okay. So now you can see it's a bit different, and in the tree over here you can see baffle. So now I just need the mesh. I'll just go back so you can see how the mesh looks like. And I'll just go to mesh. Remember to save once in a while. It the save button only works when you are in when you are preparing the mold. Otherwise, it works a bit like a database where every step you do is saved automatically. But anyway, I'll generate. I'll just control here how my cooling channels are meshed. Let's see. Oh, it seems a bit weird. But anyway, 2 inner and 3 outer, that's good enough for the cooling channel. And the part is meshed with 5 binary layers. So I'll go to generate, and I'll put the mark here. So now I get the solid mesh of the part, and afterwards the meshing of the runner. And remember we did the symmetry, so we have a cut here, the symmetry plane, and now I need the mold base mesh, so I'll just generate here. And you see the baffle did a solid mesh where it goes up here and there. And now I got this mold base mesh. I'll say final check. And it's ready for the analysis. If I can hit this transparent, and if I use this again tool chisel, you can actually see, if I cut through here, you can see how the mold base is fit into this. I recommend using the setup like this, where you take off this one and also use AutoGrid meshing cooling system. But you're allowed to do everything. This is the way I do it, is just what you call the old-fashioned way, where you are sure that there's a mesh matching between the mold base and the parts. So now we have the material here. It should be updated. I'll just hit here and say this one. Yeah. And the process have a red sign now. That's because it's not related now to there's new features now because we have to define the cooling. So and also the mold base material. So I'll just double click this one and new and reset to default settings here. And now like before, I put in the machine capability 5,000 bar and yeah, in injection pressure and so on. I'll give in this and the filling time and the packing time. I think I had 10 here. Refers to machine pressure. Always have this one. I'll go down here and say 400 bar for 10 seconds. Then we have the melt temperature. It's from the data comes from the material and also the mold temperature. And this is just an initial mold temperature, you can say. And then you don't need to change this one to transient if you want to run a transient analysis and see how the temperature development through the startup is, then you have to change this, but in this case we don't change it. And then we have the cooling time. I'll give it in 10, and also the mold opening time. If you have a very long mold opening time, it has influence on the temperatures in the mold. Then we go to cooling heating, and these are the referring to the cooling channels. As they have the same, I can't see which one is the baffle as I did. So I'll just save here, close, and then I'll go to display and look at the cooling entrance, and then I can see, okay, number 5, I need maybe a bit less flow because it's restricted by the baffle. So cooling, a normal 8 mm can transport, I'll just change this to liter per minute, transport about 7, 8, 10 liters per minute. So 7.2 here is quite good related to 8. But the 5, I'll just go for half flow. Okay, and then the mold metal. I have to define it here. You can use the scroll down and you can choose from here. There's a lot of different. Take this one and say OK, and then save. Yes, close. And now we have to choose a different analysis type. So I double click the analysis here, and the sequence I need now is this transient. I choose this one and say save. And computation parameters, I double click here and say reset only inconsistent setting to the default. I use that. So the packing time step, I'll just control that fits the 10 seconds. It does. Run fiber analysis here. I have fibers inside. Yeah, and then the cooling here. I can choose to run the simulation by a network analysis or 3D CFD calculation of the cooling water. I'll just use this network analysis. Then it takes into account the 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 flow inside the channel. But the cooling here, I'll click here, say edit. I'll see 10 seconds Okay, I have 19 results, so the cooling will be calculated each half second. I'll go with that. And the opening 3 steps, fine. And then I go to the warp. I need this one, and I need this one. So I have everything. And now it's just start up the analysis by clicking here and then choose a server and then upload uh, for simulation. Okay, thank you for watching. Bye bye.